Good afternoon, everyone. Thanks for joining us today for the second session of the Florida Tropical Training. We're excited to have you here with us today. My name is Jessica Few, and I'm one of the lead forecasters at the National Weather Service in Tallahassee, Florida. We're also joined by Dan Noah helping us today, who is the warning coordination meteorologist for the National Weather Service Tampa Bay area in Ruskin, Florida. We are your moderators this week, so you will see us through Friday, either on camera or behind the scenes. Today's topic is wind threat recognition, impacts, and messaging. Before we get into introducing our speakers for today, we do want to mention a few logistical items. We do have a large number of participants on the call today, so please use the questions box on GoToWebinar, and we will answer your questions at the end of the session today. In addition, we are recording this session, but we're only recording the presentation portion. We will not be recording the Q&A session. So that will also be available on Monday, next Monday, this coming Monday, to be able to get all of the recordings from this week and additional documentation. So again, today we are talking about wind threat recognition and messaging and impacts. And then we have 3 more sessions coming up for the rest of the week. Our speakers today are Pablo Santos, who is the meteorologist in charge at the National Weather Service in Miami. We have Dave Sharp, who is the meteorologist in charge at the National Weather Service in Melbourne. And we also have Michael Spagnolo, who is the deputy state meteorologist at FDEM, and he'll wrap up today with a few comments from some of their experiences. So Pablo, I will go ahead and toss it over to you to kick us off for winds.
Is going to be who is going to take it from there. The slides that I'm going to talk about here begins with this graphic that you have, all of you have in front of you, and it speaks to the motivation behind why we communicate the wind threat and potential impacts the way we do. If you think of this graphic, this is a spectrum of possible outcomes. You can think of it that way. We also use it to explain the concept of risk tolerance, but think of it for the moment as a spectrum of possible outcomes. Of course, the future forecast from the Hurricane Center is right in the middle, okay? And it's often referred to as the most likely scenario, whether it is relative to an area or a specific location. If the forecast were to be perfect, then you can describe it as what is expected to happen. But we know better than that. In reality, beyond the most likely scenario, which is the forecast from NHC, you have possibilities that could entail worse conditions or stronger winds, or you have possibilities that could entail lower winds or better conditions, right? For that last one, we often refer to those possibilities if you plan or prepare according to that as living in the margin of danger, right? This is something we do not want people to do. Dave, go ahead, go to the next one. And the reason for that being that over the years from experience and also from our work with social scientists, what we have learned is that often in time, people latch onto that piece of information that will justify them doing the minimum amount of action that they need to take. So we do not put a lot of emphasis on that. So we focus on the official forecast, or what we refer to as the most likely scenario, along with a reasonable safety margin to account for potential reasonable worst cases that could ensue. So, but let me talk first about the official forecast. What does it look like? And why there is a need for us to go into that margin of safety. So go ahead to the next one, Dave. This graphic here that I'm going to show you next shows a forecast, a wind forecast based on Hurricane Michael Advisory number 8, and it's a peak wind swath of that forecast based on that forecast, which was about 50 hours or so from landfall. This graphic, just to explain it here in simple terms, any areas that you see there with the color green is less than tropical storm force winds. Any areas you see in yellow are winds of 39 to 58 miles per hour. Orange is 58 to 73. And the red are hurricane force winds, winds of 74 to 95, category 1 or 2. And if you see purple, those are major hurricane force winds. And what I want to bring your attention to is Coastal Bay County, which is the county that is encircled there on the left of the image. If you notice within that county, If anybody were to be looking for information on the specific wind forecast across the western part of the county at that time, based on that advisory, well, the most likely scenario was speaking at that time of winds below tropical storm force. That is the green color. For people living on the extreme southeast part of the county, hurricane force wind, the red. And any minor juggling in the track could actually bring the sliver of purple, which is major hurricane force wind. Now think about it for a second. This is 2 days out, and this is what the forecast, the most likely scenario, is conveying. However, if you consider the typical error this far out of the forecast are 70 miles or greater, and you consider the fact that coastal bay, which is what I show on the right, is only 42 miles or so across along the coast, well, think about it for a second. That forecast track could easily be 40 miles to the left or more. And all of a sudden, you go from winds that are below tropical storm force wind to winds that are potentially major hurricane force winds. This is why we do not tie ourselves to a specific wind forecast for a specific location. Go ahead, Dave, to the next one. And therefore, that brings us to the margin of safety. So beyond the official forecast, we want to factor a reasonable margin of safety that speak to a reasonable worst case scenario, okay? And that is to make sure that people do not get caught unprepared. And this is really the motivation behind this talk. So with that, I'm going to go ahead and pass it on to Dave, who's actually going to dive into the reasoning behind how we communicate wind threat and potential impacts. Dave, go ahead and take it away.
Okay, well, thanks, Pablo, and thanks for that great motivational intro, and really kind of exploring or maybe setting the stage for explaining why we do some of the things that we do and why we say some of the things that we say. And so I'd like to spend the next little while sharing with you the idea of messaging the wind threat and the corresponding potential impacts that are associated with hurricanes and tropical storms. Simply and fundamentally, how do we, as meteorologists here at the National Weather Service, whether it's here in the field offices at the WFO or at the Hurricane Center with a hurricane specialist, how do we use the best technology? It doesn't matter if it's high resolution satellite information, or perhaps we're using Doppler or even dual pole radar these days. And then there's just this, with high-speed computing, there's this great advance in high resolution diagnostics and prognostics, or analysis and forecast, if you will, of hurricanes. We have a lot to choose from, a lot to consider. And then we can take that information actually and generate wind speed probabilities. So we've got technology, we've got modeling, we've got science, we've got all these things that are at the scientist's disposal, and it's all in our head, and we've got to get it out of our mouth and into your head as community decision makers. And so how do we go about using all of that great information to assess the current tropical threat to our communities, but also knowing that we have to communicate the corresponding potential impacts to the people? Because ultimately it's about the people, right? That's why we do the things that we do. And we all understand, you know, as partners, that the majority of the National Weather Service, in terms of our partnership and our customers, are not hurricane experts. You don't speak in hurricane terms every day. And the irony to that is that when it comes to the National Weather Service across the country, most of the National Weather Service, they're really not hurricane experts either. So there's really only a kind of a slim margin of folks. But even those slim margin of folks, as we interact with each other as customers and partners and supporting cast members here, if you will, that when providing weather information for planning purposes, we, the National Weather Service, must speak your language. And that's incumbent upon us to do that. So we have meteorologists, forecasters, METs, right? The folks that are using all that science, all that technology, right, and putting it to good use. And they're communicating with decision support specialists, the DSS person there, right? And that decision support specialist is supporting the EMs who are making community decisions. And that's how we get from the forecaster on the floor information in the DSS forecaster's head and then into the ears of the emergency manager so that good and effective decisions can be made and enacted, right? And again, all of this effort is, to support our missions to protect life and property. So we have all this complex tropical wind information, and we, the National Weather Service, are trying to learn how to distill it, to make it concise, to make it more focused, to translate it for you so that it's converted into easy to understand language. In other words, it's not dependent on being a meteorologist. It's not depending on being an emergency manager. It's a common and easily understood language. But we also want to make sure that it's properly interpreted, right? Because as we change, you don't want to lose things in interpretation. So we want to retain the meaning of that message. And we want to put it in relatable terms, right? Because relatable terms, that's actionable. Albert Einstein once said that everything should be made as simple as possible, but not simpler. And that's the mantra that we try to live by as meteorologists and decision support specialists helping out community decision makers. It used to be that we would go and do all these things relative to the weather, and then we make the assessment of the hurricane and so on and so forth, and then we just start communicating right away. And then we realized that we were losing information pieces along the way, that people weren't hearing everything we were saying, or misunderstanding or misapplying what we were saying. And looking back on it now, we can kind of understand why. Because what we were doing, we were missing a step. We were assessing the threat, but we were not interpreting the impacts. We were not recognizing those potential impacts that might occur. We weren't putting it in relatable, understandable language. So when it comes to general customers, right, when we put out those standardized products and services, the forecaster out on the floor, even at this moment, they're operating on universal thresholds, tropical storm force, hurricane force wind speeds, and they're delivering those standardized products, the hurricane local statement, and they're going through dissemination systems in a standardized way and providing traditional support. And it might be, some of it ends up in your lap, but some of it also heads to the neighbor next door, right? But more importantly, when it comes to community decision makers, we understand that you have unique thresholds also, right? You're a specific customer with a specific need. And so we try to tailor that information and that delivery system to meet your needs and to provide you with dedicated support. So in the process, we know that we have to communicate forecaster to forecaster, right? Decision support specialist to the community decision maker, so that we're all saying and understanding the same things. And that's quite an orchestration. And it doesn't sound like much, but that actually has been a very big advancement over the last several years. Because the short of the matter is this: we kind of feel that you could do your job better if we do our job better. So we understand that we don't make the decisions, but it's our job to support you in making those difficult and arduous decisions. The mutual intent with the National Weather Service to protect life and property, and with the emergency management to protect life and property, that our mutual intent as a forecaster, let's say, is not to provide you with a perfect forecast. Although things go a lot better if we could do that, right? But the mutual intent, yours and mine, is actually to change the outcome of the event based on the information, the forecast that we have and that we've rendered, right? To change the outcome of the event, to limit the extent to which lives are lost and property is damaged. Now, we know that our partners live life in a holistic way, right? But here in the forecaster world, we make our assessments individually, hazard by hazard, and I'll show you what I mean here in a moment. For decision makers, the wind hazard is often the modulator of a hurricane event or a tropical storm event, right? We know that there's, flooding rain potential, there's storm surge potential, all at varying amounts depending on the storm, depending on the location. But really, it's that wind hazard that gets things going and kicking most often, right? And so it's the modulator of the event. And so forecasters, we tend to assess the potential of sustained winds, of gusts, of tornadoes, of landfalling water spouts, right? But we know from a wind perspective, as I've shown here, and then you can throw all the other hazards in too, that the hurricane comes at you holistically. All these things are happening in motion simultaneously or in succession. But for you, the decision maker, you're trying to adjust and adapt to all of it coming at you at the same time. So we need to make sure that we communicate in that way. So we know that, you know, you're planning for threats, you're preparing for impacts, and you're acting on thresholds. So our information, our messaging is beginning to posture that way so that we can communicate with you and also with the public, because, you know, they're decision makers too, to help you all plan for threats, prepare for impacts, and to act on those trigger thresholds. Now, for you all, trigger thresholds might be a certain level of wind or the possibility or probability of a certain threshold of wind, right? We know that that can be trigger thresholds in your plans and playbooks. But for the neighbor, the trigger threshold is that issuance of the watch or that issuance of the warning. So we want to be able to support both community actions, emergency management, but also family actions in the neighborhood down the street. So our decision support messaging, specifically as it relates to wind here, is we get at the what of the issue, the where, the when, the how much, the how long, and the how sure. You need information about those pieces in order to make effective decisions. The why of the matter, we reserve, you know, for another time. You know, it's related to the looming hurricane event, right? But the why of something has to do with trust. And trust, well, that's built during the off season. We'll talk more about that at another time. But when it comes to public safety messaging, the neighbor across the street, they also need an additional piece of information. And that's called, what am I supposed to do about it? So you've given me all this great information, you distilled it, you translated it, you interpreted it, but still the neighbor wants to know, what am I supposed to do about it? You and I, we already know because we have hurricane plans, you know, being enacted in their proportional ways. And so our message to the community, to the public, begins to be targeted. Coastal residents, those living in high rises, those with special needs, those living next to a swollen river, right? That's targeted messaging. The idea is to get the right people targeted to do the right things at the right times. If we do that together, our mutual intent will be satisfied. We will change the outcome of the event. But, you know, messaging always comes with its challenges. There's conflicting and ambiguous information out there. It leads to confusion, and that confusion, of course, that inhibits effective decision making. It leads to delayed actions. And so we really need that clear, consistent, and unified messaging thread, right? That's key to the process. It doesn't matter if it's internally within our respective agencies or among the partnership ourselves, but certainly with the public and for their benefit. So we might put out something, here's something from the Hurricane Center, right? It's a good series of information. It's a little bit verbose, but there at the end, they sum it right up. The bottom line is this, right? I said all that to say this. The bottom line is be alert, be prepared, but also wary of long-range predictions or projections that goes beyond what the science can offer. And the next thing you know, that projection of a 10-day forecast that was found somewhere out there on the internet, right? That's basically a gnat in somebody's eye and distracting them from the real issues at hand. And so the ability to get to that bottom line is very, very important. And if we're not doing it, you need to let us know. Because it comes to us like this. This is a simple, you know, curve. It's a kind of a little spectrum there, if you will. And at the end of it, to the right-hand side of the graphic here, it's let's say the WFO knowledge. This is local knowledge. It's Dave's knowledge about the looming wind threat, right? Well, at day 7, I probably don't know very much, right? I know something's there. I know that the threat is not 0, right? But as the event or the cyclone or the hurricane or tropical storm gets closer and closer in time, then my knowledge of that information or that threat increases. But my knowledge is not 100%, ironically, until right at impact time, and most likely not until right afterwards. And so there's a series of products and services that we provide and ways in which we speak to you as decision makers and also unto the public. And you'll see that as we move from planning and preparing to implementing our plans to dealing with that last chance to save a life and then into the recovery mode, we must learn how to speak with increasing specificity. It does no good for me to explain or to say or to declare unto you an exact wind speed for an exact location at day 7 or even at day 5, right? It's going to get us all into trouble. So we basically walk that storm towards us, right? We get more specific about the threat situation as the event unfolds. The public gets information from a variety of sources, emergency management, National Weather Service. They also get it through the media. And then now all of a sudden, social media is a big part of that now over the last several years. And again, there you are. There's that 10-day forecast and somebody saying, hey, you better start getting ready. Well, what we want you all to know, the National Weather Service values our partner relationships with you all and being a trusted source, the WFO, the field offices, and the National Hurricane Center, right? And when it comes to the rainfall and the tornadoes too, also our other national centers, to be that trusted source, because we want to provide you with reliable and consistent information that's good for decision making. And, better start getting ready doesn't really, say much, but it can be a gnat in your eye. So be very careful about where you pull information from. So at this stage of the game, I've got a poll question for everyone, and I'll ask Dan to go ahead and fire up the interactive part. But here's the question. Before tropical winds arrive, which of the following options should you use as your planning forecast if you want to fully err on the side of caution for safety's sake? The latest official forecast, a most likely alternative scenario, a reasonable worst case scenario, or just some update from a weather app that you just found? Give it some thought and submit your answers. Dan?
Okay, looks like we've got the results that are in. Let's see.
Okay. I can't see the poll, but I'm going to give you the answer. Now, I'm quite sure that there were quite a few answers that filled up our multiple choice question here. Hopefully not too many of them in the D category, right? But, you hear these terms, the latest forecast, the latest official forecast, the most likely scenario, the most likely alternative scenario, the reasonable worst case scenario. What in the world is all of that? So thank you for answering that question. And hopefully we've piqued your curiosity, and we'll go ahead and look at these. So as we begin to interact with one another, forecasters and community decision makers, in order to simplify, forecasters are likely to approach you with one of these 4 scenario types, perhaps maybe 2 or 3, but depending, and we'll look at it. But we're going to describe the latest official forecast. We may refer to something as the most likely scenario. Occasionally, if it's called for, we might talk about a most likely alternate scenario. And then you may hear us talk about a reasonable worst case scenario. So let's look at these a little closer. The latest forecast is exactly that. It's the latest forecast. It's the official forecast. But what you need to know about that official forecast is it's very deterministic in its nature, very exacting. It comes manifest in several ways. It shows up in actually here at the local level, it shows up in our local forecast, our county and zone forecast, you know, even all the way out through the 5 to 7 day forecast, when we say, hey, east winds 45 to 60 miles an hour becoming southeast after midnight with gusts to hurricane force or 75 miles an hour. Wow, okay, that's pretty good, right? So uncertainty is not really taken into account. So you may be hearing us talking about, and something a little bit more familiar, is a most likely scenario where we begin to introduce measures of uncertainty. We put the error cone on there. Oh, okay, the track could be a little to the left, it could be a little to the right, right? And then we realize the storm has size and structure and intensity, and all those things come into play too, right? A most likely scenario typically approximates the latest forecast. It's mostly deterministic, but it does account for some uncertainty in the process. Hey, even in our watches and warnings, let's say a watch, you know, hurricane conditions are possible, right? So we're introducing some measure of uncertainty. Well, here's the deal, and this comes from Pablo's motivational talk there. The sole use of the latest deterministic forecast, or that most likely scenario right there, if that's all we go with, right, that can be problematic for decision making relative to very high impact events, right? Those major hurricanes that are about to make landfall. If you don't account for uncertainty, whoo, it could be tough. And if the forecast itself is particularly challenging, right, you know, here comes a landfalling major hurricane. We can very emphatically say, hey, north winds at 90 to 100 miles an hour with gusts to 135. Well, what about the county to the north? What about the county to the south? And if it happens to have some broadness, like Brevard County, you know, where? North end of the county, south end of the county, you know, so all of that comes into play, and we have to find ways to communicate that, because if you and I can't get together on it, the neighbor doesn't stand a chance. So sometimes the risk is just too great to just say, give me that forecast, right? Give me that gut call. Sometimes we talk about a likely alternate or alternative scenario, and that just means that if our most likely scenario may not pan out, in other words, the storm may go this way or it may go that way, right? Not because we don't know, it's just because if it develops more, it may start pulling to the north, or if it stays shallow, it may just continue to drift to the west. And those are things that we know, so it's going to do one or the other, right? And so we might give you that alternate scenario, right? It's a secondary contingent forecast of what if forecast. We don't use it all that often, only when it's called for. So if you hear us use it, you'll say, oh, this is a little bit unique, or oh, must be a challenging forecast. Do you all remember Erica from back in 2015? On the lower left, you'll see on August 27th, looks like Erica is going to try to go to the east side of the Florida Peninsula. And then the next day, it was like, well, maybe to the west side after, you know, traversing Cuba. And then by the next day, the 29th, on the lower right-hand side of the screen, Tropical Storm Erica has been degraded to a low-pressure area. Wow. Where'd it go? That was it. Poof. Well, where's the center of circulation? Why is it, you know, being relocated? Is it going to go over the islands? Is it going to go over Cuba? How torn up is it going to get? There's a lot going on right there. And so when those cases come about, sometimes you'll hear us talk about an alternate scenario. But more importantly, we like to talk about wind speed probabilities. And so when that official forecast is made, right, we can generate iterations, variants, right? And we'll run 1,000 of them, right? And so let's say, for example, take New York City. We'll put a location there. And so when we run all those variations, all those individual members, all those different little scenarios, how many times does tropical storm force winds, let's say in this case, actually are they attained in New York City? And so out of 1,000 runs, it was 590 times that happened. So the probability of tropical storm force winds at this moment for New York City is 59%. And that's how those are generated. And from there, we can have tropical storm force wind speed probabilities. We can generate hurricane force wind speed probabilities. And then we can take that information also and generate time of arrival of tropical storm force winds, because we know we want to get, all our preparations done before those tropical storm force winds arrive. We can talk about a reasonable, an earliest reasonable time of arrival, a 1 in 10 chance, or we can talk about that most likely time of arrival, right? That 5 in 10 chance. When you're farther out in time, when the cyclone, still hasn't made it past Jamaica, you're probably going to want to use that earliest reasonable time. But as the event gets closer and closer, we can begin to get more confidence locally if the cyclone is well behaved and well forecast, and we can start to use that most likely time of arrival. So we want to use the earliest reasonable during, early in the event, let's say at the watch or pre-watch phases. But as you move forward through the warning time, we can make refinements to the arrival times. And those two information pieces are helpful there. This is how that information might come to you in a briefing, right? Here's a briefing from Matthew. I tried to keep the examples the same so that they were easier to relate to. So, for example, here's a slide. It says, here's the situation. The probability of tropical storm force winds at Fort Pierce is 24%, right? So you see the little X there, Fort Pierce, 24%. And so we give the information in probability form, but we also give the information in odds form, 1 in 4 chance. There's a 1 in 4 chance that tropical storm force winds will be realized at Fort Pierce. And we also like to give some trend information. So, according to the latest forecast, sound familiar? A most likely scenario still keeps Matthew to the east of the Florida Peninsula. But an alternate scenario, Dave's talking about an alternate scenario, so there must be a challenging forecast, could bring Matthew closer to east central Florida. But you know what? It's too early to describe exactly the type of impacts we're going to get from Matthew at this point in time. But here's the key point. It's possible for a major hurricane to be in vicinity of east central Florida by mid to late week. So you see how we use that scenario language, right, to bring forth information about the wind threat. And that leaves us one more, that reasonable worst case scenario. What is that? I've heard that a lot lately, and why do they do that to me? Well, it's probability based, and that's kind of the key. Remember what Pablo talked about early in the presentation, and he talked about the margin of danger. Well, you don't want to hang out over there. But sometimes that latest forecast, sometimes that most likely scenario is not good enough. The risk is too great. We have to factor in a safety margin. Well, how much safety margin? Well, if you use the widest extent of a reasonable safety margin, that's your reasonable worst case scenario. In probability terms, it just means there's a 10% chance of the event being exceeded. In other words, if you plan for what's being depicted 9 out of 10 times, it's not going to get worse than that. You're going to be okay. 1 out of 10 times, it may occur, but to accommodate that, at some point it actually becomes unreasonable, because then you're preparing for every cyclone like it's going to be a major hurricane or a Cat 5, right? So we try to keep it reasonable, but also a good safety margin. So when the safety margin is exercised to its widest extent, that's what we call the reasonable worst case scenario. It's done for safety's sake. It's a solution of least regret, right? You know, you may be spending more money, you may be, spending more time, you may be sweating a whole lot more, but after the event, 9 out of 10 times, we're going to be okay. It's about risk tolerance. So you'll see that reasonable worst case scenario factored into to wind language and especially into surge language, right? You'll learn more about that tomorrow as we talk about evacuation planning. But we want to err on the side of caution. Okay, consider this. We have a hurricane watch in effect now for East Central Florida, and son of a gun, if it doesn't look like Matthew's exercising that that most likely alternate scenario that we were talking about, right? All right, so it's a major hurricane. It's a Cat 4. I know that a hurricane watch is up, but depending on where I'm at, what extent do I make preparations against the wind? Well, it depends on where you are. It depends, well, okay, well, show me, tell me, right? So if you look at the map on the left-hand side, those areas, those locations that are highlighted in purple represent those locations that should be preparing for a major hurricane winds. The red, Cat 1, Cat 2 winds. Orange, strong tropical storm force winds, and you get the point, right? And we use calibrated probability information to show that depiction. Well, you don't need to know all the probability information under the hood. You just need to be able to say, hey, wow, looks like my barrier islands have turned purple. I better prepare for major hurricane force winds. Or if I'm in Orlando, maybe I better prepare for strong tropical storm force winds in order to be safe, because that is what you're seeing there is that reasonable worst case scenario. And we can take that information and we can do the same thing with the other hazards, surge, flood, tornadoes, and we can calibrate the levels and the corresponding probabilities that go along with that and begin to tell you, depending on where you are, but hey, pick a location and say, oh, in your location, whether it's this graph is, the bar chart is specific to East Central Florida, but we could do it by county, right? We could do the same bar chart by county and tell you exactly what, hazards are threatening you more, relatively speaking, to the other hazards. And you know what? That kind of stuff translates very well into the neighborhood language. And it's easy to coordinate with our media partners, and it's easy for them to communicate that to the neighbors, right? Now, all of a sudden, the emergency management, the National Weather Service, and the media are all saying the same things. And boy, when you get 3 sources saying the same thing, right, the neighbor's going to get off the couch. And that's really what's important. Because as a major hurricane or a hurricane approaches and it's still 48, 36 hours out, right? And in this case, it's a major hurricane approaching Southwest Florida 36 hours out. What are you going to tell the folks at Fort Myers and Naples? Is that thing for sure going to become a Cat 2 before it gets to me? It's gonna weaken a little. Or what do you tell the folks in the Keys or in Tampa Bay? What do you tell the big population center in Miami? You can't go with that latest forecast, that deterministic forecast only. You can't just exercise the most likely scenario. You have to exercise. You have to exercise that reasonable worst case scenario so that everybody, to the best that we can, lives on another day. We're getting kind of near the end here, but I just wanted to share with you what it looks like in text form, because you see this TCV product, and what are they talking about, the TCV? Well, in a lot of ways, the information that was shown to you graphically a moment ago, there's just, it's all available in the TCV Text product. That's information county by county, zone by zone. You get wind information, you get surge information, you get flooding rain information, and tornado information, right? But let's say in this case, we've got it here for Miami, is Miami Beach, downtown Miami. The top of that little section, you get the alerting information, the bells and whistles, right? Emergency alerting system, if you will. You get the headlines, you get the locations, right? For the location you're talking to. But here you go. That information, if you just got to have that latest forecast, we provide it to you. It's right there, right? The forecast is 55 to 70 miles an hour with gusts to 90 miles an hour for a peak wind forecast. That's the most likely outcome, right? But is that all you're going to prepare for? You're not going to factor any uncertainty into the equation for Miami-Dade? Well, if you need to, want to, should, then you look at the threat section. It's depicted for you there graphically, but it also survives or lives in textual form too. It says, hey, you better at least prepare for a Cat 1, Cat 2 force winds in this situation. And if it happens, the bottom part there, that's what it's going to look like. This is what's going to break. This is what's going to fly around. This is what it's going to look like in the morning. Hey, my community is being threatened by a major hurricane. How about Hurricane Dorian? 185 mile an hour winds with a hurricane that's moving west at 5 miles an hour. What do you think Martin County's going to do? What do you think Palm Beach County's going to do? Right? They got a hurricane watch up, or warning up. That's good. But this thing's 185 miles an hour. There's the forecast. 40 to 50 mile an hour winds with gusts to 75. Imagine if all that was done was to prepare for that. You'd say, well, you know what? They got through it all right. Well, that was a lot of danger that you accepted. Rather, consider the extent to which preparation should be made. Plan for life-threatening winds of equivalent Cat 1, Cat 2 force. Prepare that remaining efforts to protect life and property should be urgently completed. Prepare for considerable wind damage. And depending on where you are in the event phase, act. Move to shelter before winds become hazardous, which is what you and I can tell the neighbor. Those threat statements have been sculpted to 140 characters or less, which means you can tweet them. And we had to go to 140 characters, but I know you can do more than that now. But they're excellent for sound bites, social media posts. You can facilitate media messaging. You can facilitate TV crawls. Hey, you might even be able to facilitate smart devices, apps and smart signs and the things like that. All of that information is all consistent, all based on the threat situation at the moment, and all good for unified and consistent messaging. And again, if necessary, we can communicate that information in terms of, hey, could you please tell me what 185 mile an hour might look like tomorrow morning? Or I need something to relate to so that I can tell the neighbors. Well, there you go. It looks pretty bad. We can give information about structural damage to the area, trees and foliage, roads and bridges, and essential utilities. And then finally, as we look at this, I want you to consider that safety margin one more time. Here we are. Here's the map, if you will, with that official forecast, orange, and that widest safety margin there in green, right, which is the 10% exceedance, right, the scary language. But if I want to narrow it up, the closer that storm gets, the closer that hurricane gets, and refine my decisions, I can do it. I can do it. I can do it. I just have to coordinate with my decision support specialist. So here's a poll question, and probably what we'll do is end up here. For each county zone, what tropical wind information is included within the TCV Text product? For each county or zone, what tropical wind information is included within the TCV Text product? Dan?
They're answering now. Dave, if you look under polls under your go-to webinar pop-up box, you should be able to see what's going on right now.
Oh, there it is. Awesome.
Okay, I think that's everybody
That's it.
gonna vote has voted.
And you guys did great on that. You guys did great on that. I think not only did you hear Pablo, perhaps maybe I was of a little bit of a help to you, but I think that you brought a lot of this information along with you. And so I'm glad that we were able to reinforce that information today. Very good. So in just a few slides or two, I just wanted to let you know that we do have that information, that threats and impacts information on a website, right? The website, it can be found at www.weather.gov SRH tropical. And in fact, once the watches go up, it's for sure the HTI, hurricane threats and impacts, is going to be there. But going forward this season and beyond, we're going to try to provide it even at 48 to 72 hour time frame if the threat is consistent enough and forecast trends continue. I have the definition of when we'll do it. That's mostly for our forecasters in the room. But I just wanted you to know, especially at the state level, because you want to see the mosaics, right? At the state level, that we're going to do our best to provide HTI at the 48 to 72 hour time frame. So whenever the day 3 error cone has overspread part of the WFO's land-based areas for 2 consecutive advisories, and that the forecast trend continues to show some measure of impact, we're going to do it.